I just remember the call that I had with Howard, and Ryan was on the call too, and he'll be presenting shortly. And it was just this really surreal, crazy moment where when you have this like wild dream in your head and someone's describing it like vividly as if they had like access to your like deepest like, thoughts. And that's when I knew that what we're talking about here, what we're working on, it really is the future of an industry, this gardening industry. It really is this massive opportunity to, potentially have AI and other technologies like we've discussed, including 3D graphics, augmented reality, virtual reality, all of these visualization tools to come together and just really to start to truly augment the intelligence of landscape architects, and augment the intelligence of the average gardener buying a plant. So that's really what we're going to talk about. That's been the focus of it. And I'm thrilled to have, the talk that we just had. I was telling them that like, they're the doers. If you want something, if you want an app built like soon, talk to those guys. Because, if you want to invest in a company that's been around for 5 years, researching these topics, but not building many apps, we've built some apps, but we've really been going big and long for the whole thing. So when we talk about photorealism, when we talk about accurate simulation of what plants are appropriate for the site, these are things that we really care about and have spent a lot of time on. And I'm going to present that now. So I have to say, he's probably watching. Basically, he's my co-founder. His name is Rob Cohn, and he's got a PhD in AI. He's worked at Google and Microsoft. He's a huge part of this work. He couldn't be here with us today, but basically, really grateful for him. He and I together have coded most of what we're presenting. I'm also intentionally presenting I'm assuming you're mostly a non-technical audience, but you would like to be aware of what's out there. You'd like to be able to point to tools if you have your own developer, or you just want to know, what's actually developed today in computer vision and in 3D reconstruction, as well as in, plant classification, these things I'll talk about shortly. So basically, what I'm just trying to get at is giving credit to Rob and letting you guys know what this is going to be. So I just want to start with saying, oh, by the way, please interrupt or ask questions. Want to make sure if something's on your mind, you can just go for it. So, yeah, basically, as of today, I think the goal for this company, 3Co, which has basically been funded by Techstars and other investors, and has been heavily bootstrapped from us, is basically to 3D model all of the world's plant species using AI. So when we talk about, the challenges of like manually adding textures to these trees and stuff like that, I'm just like, I'm not going to do it. Like, there's too much complexity. There's too many species. And in the case of plants in particular, it's a good reason why a lot of people love to spend time in the forest or something, because there's just so much discovery to be had. And, it's not like there's just one or two things that we have to 3D model. There's approximately 10,000 or 30,000 different, plant species in a commercial marketplace that we would need to accurately 3D model so people can actually get a visual sense, at least approximately, of, what these plants would look like around them in their garden or their, any kind of commercial urban environment, basically. So our goal is to 3D model all of the plant species. Our goal is to just, at some point we thought we might monetize distribution of 3D models. We're ready to give them away. I think there's a whole bigger future that we want to be a part of in actually creating the gardens and in actually working with developers, working with landscape architects. And we want to be in the business of developing the real world. And so in our case, when it comes to letting people use these 3D models for their own purposes, please talk to me if you're interested in that, because we're going to be giving that away. And we also want to develop our AI for individual applications. Howard's got stuff with L systems, and there's other projects with invasive species monitoring that we just put together a grant for. We're very interested in all of these things, so please just reach out to us if you have projects that you're interested in the space. Yeah, go for it.
Just ballpark, how many plant species are we talking
about? Like in the world, or? Yeah. Well, I'll actually get to that in a moment, so okay. Just hang on. I'll answer it right away and say the last database crawl we did was 100,000. But that's just for observed plant species that we've actually documented in the database that I'm using, which is a very big database. But I've read there's 300,000. So probably a lot in the Amazon rainforest, that kind of thing. that doesn't get documented. Is that the question? Or?
Yeah, I just figured there would be more.
It's fascinating. Yeah, I think 300,000 is the approximate, and then we have access to 100,000 right now, which is a little bit of preface. So yeah, and basically I mentioned augmenting intelligence of garden landscape design. Aesthetic intelligence is a thing, but does this look good? We really care about helping people to answer that question. Ecological intelligence, this is a big question. You know, is this going to be an invasive species? Does this pollinate for the local native butterfly? You know, I was asking someone at Fairchild Botanical Gardens butterfly exhibit, I was like, what do we know about like the sort of connections between, you know, plant species and butterflies? And they're like, well, they didn't know anything at least. So, you know, it seemed like we need to put all this into AI and allow AI to help people to capture, you know, supporting native ecosystems and supporting, you know, future ecosystems that are biodiverse and, you know, not just plants, but all the things that plants support. And then last but not least, because this is where we're going to actually survive and make our money from as a private company, you know, commercial development of landscapes, basically. We would love to be involved in the process of rendering the landscapes and the process of people making decisions to buy the landscapes that are being rendered. And, you know, we'd be happy, like Amazon, to take a cut of that. So that's just, that's our full disclosure of what we're looking to do. But we think that there's so much opportunity to bring AI to just help regular people and experts to improve their capacity to design landscapes. So yeah, so basically the end goal, like when I'm done, when I'm in the grave or whatever, I want to be able to look up and say, okay, we planted millions of new gardens. And I think that's a really ambitious goal that genuinely inspires me to work really hard. And it's not a 1 year or 2 year thing, it's a 50-year goal. But I think we absolutely have the possibility to use AI and XR to inspire people to just go to the next level of beauty in their environment. And I really want to emphasize my perspective on a lot of these things because that's what motivates all of this hard work, really. Okay, so I mentioned that this is the goal in a nice, concise summary: develop beautiful and sustainable environments through artificial intelligence. Really happy to shout out to this garden here. My favorite garden designer in the world, Pete Tudolf. I got a chance to visit his private gardens in the Netherlands. And he also designed the Highline Gardens in New York City, which of course has been a very, very big project in urban development. And this is Tudolf right here. Vogue recently called him the world's greatest living landscape designer. And, you know, that's a cool photo of him. He's actually a bit younger here. So this is him and he's had a little bit more gusto in him. But now I'll tell you what, he's got all the gusto in terms of what he's doing today. Many cities are hiring this guy to create more and more extremely biodiverse, naturalistic style gardens that look like nature, but are completely engineered. And, you know, the big question is, you know, well, most people, 100 million gardeners, that's my approximation, they don't understand what it would take to create a garden like this. They don't have the intelligence in horticulture that he has of several hundred species, and they don't have just that vision for 3D landscape design that he has. And he's just an example. I'm keenly aware there's literally hundreds of you know, amazing landscape architects regionally and worldwide. I think we want to work with them to improve their abilities and also to extend their abilities, to scale their abilities, so that regular people can suddenly have the ability to plant beautiful gardens. So, you know, really what we're talking about, though, is something a little bit bigger and something a little bit different than just gardens. It's not lost on me that, you know, if we master the ability to plant a garden and do so with photorealistic simulation, there's a lot more that can happen. And more generally, this does seem to be a trend of augmenting human vision. That's the Apple Vision Pro device, as you would expect it to have in your hands. So anyways, I mentioned a few times already, I'm really excited. It's been a long time waiting for this device, and it's finally coming in a few months. So, you know, you can trust that Apple's just has worked out a lot of the kinks, and from what we've seen from early demos, just consciousness of like shading, having a little floating panel be shaded automatically underneath. It's those subconscious subtle things that will prevent motion sickness and allow people to feel just more, you know, seamlessly immersed into an extended reality. So it's going to be exciting. It's going to be early stages. This device really should look like normal glasses within the next 5 years. It really should look like that. That's definitely the vision that everyone has here. So, you know, the idea is that it's not necessarily going to replace our phones, but this is what Apple, Meta, Google, all of these guys are saying this is the future. So, you know, we're playing into a bigger trend here. Okay, so what are we looking at? I wanted to just briefly talk about mostly, so I wanted to give you motivation, give you some bigger perspectives, but now I'm going to actually dive into computer vision and 3D reconstruction. You know, before 2020, I was just talking with Austin about this. You know, it was a Wild West, and basically, like a lot of these techniques barely worked. And so you really didn't have recourse to, you know, neural networks or artificial intelligence. And because what I'm saying is that this big robot-looking simulation thing is exactly something that my company developed. I built the real thing in Amsterdam with some engineers. We had a $20,000 LiDAR laser, super precise 3D scanner on the head of it. And it had the ability to automatically move around objects and capture 3D scans and then fuse them together into 3D models. And, you know, look, I think it's great. Most of that hardware is completely obsolete right now because now it's packed into one of these little guys right here. And, you know, also the AI to solve problems that previously in photogrammetry, especially, were there, is increasingly solving problems. I'm going to talk about what that is. Howard gave you a preview of neural radiance fields. When Howard showed this figure before we started the slides, I'm like, Howard, you stole my slide.
That's the Berkeley paper.
This is the paper though. So it just gives you a real, you know, two points form a line. And now you really see, okay, this neural radiance field's revolutionary for the field. When I first read the paper, I said, wow, that's really elegant mathematically, but I thought it was just a toy. It wasn't until the coming years that I realized this is really amazing. Howard described it. I'm not even going to go into further detail on it. But what I'll do is give you a sense. I want to say one thing on it was that the actual you know, foundation for why it works much better than just a random neural network trying to solve these problems is because it was actually physics-based equations for propagation of light that some professor from Berkeley in 1995 published, and then these guys picked it up and allowed a neural network to fine-tune propagation of light in a 3D space. Super crucial, because I just want to let you guys know what the sudden game-changing thing was. But now we're going to actually show some results. So this is actually on our website, and you can actually go to that link right now. If you want, you can go to it on your smartphone, and you can open up an augmented reality view of this plant right now on an iPhone or Android device. And basically, what I'm showing you is what sort of went into that. So on the left side, you have a camera photo. This is exactly what the iPhone camera saw. In the middle is a reconstruction of the scene that we were able to produce after. In this case, it took a whole day of a very powerful GPU just thinking about the scene and slowly coming to the correct approximate ability to render the colors. So even though I'm just showing you a picture, you could simulate any new viewpoint that was never actually seen while doing the scanning, because it's actually developed the ability to think about the whole 3D scene. I want you to understand that. And the right side is really a geometric visualization where it's color-coded so that the darkest blue is closest to you, that red is furthest away. It's really close. It's like extremely accurate, and it allowed us, yeah, go.
Do you mean the middle image can be imported into a virtual environment as a 3D object?
Yeah, basically. At this point, even Blender, people have been taking the neural network rendering, which is this represents, it's a neural network that renders the scene from any perspective. People have built neural renderers in Blender, and they work great, actually. And I would just say that I think the future of many different applications would benefit from neural rendering over meshes, even though certainly meshes are still dominant and essential to work with today.
But you invented a way to get a mesh.
We're going to talk about that.
Oh, good.
So, okay, what's going on? Oh, no.
Oh, we didn't share the video.
I guess not. Sorry, folks. What did I have here? Phylogopsis? Okay, I guess we'll just move on. That's me even. It only let me. There we go. Okay, well, I can maybe show that later if we get a chance, but I wouldn't worry about it. It's just a nice little demo. So, okay, so this is, now I'm going to talk about what happened since 2020, because, you know, the field grew exponentially. Previously, there was like, I don't know, 50, 100 researchers focusing on these topics. There's at least 10,000 to, you know, 25,000 actual people with abilities to develop these things. You could find someone on a freelancing contract who can do these things. I can do these things. So. But yeah, basically, this is the next step. So I mentioned that it took a whole day to compute a single 3D model, which is really not acceptable. We just don't have the compute power, maybe Hypergator does, but won't give it to us. It's another time. But basically, this thing was way faster. Basically, instead of computing every single point in space, as Howard was describing, it's actually a continuous model for doing that. But instead of even sampling all the points in space, which is what it does to estimate the 3D field, in this case, it just learns very quickly that it only needs to start rendering at certain parts of the 3D scene. And that's the big innovation that they implemented very efficiently. So this is a render from the neural network model from one of these publications. It was originally a synthetic scene of a ficus, but they took photos of that scene and then rendered it. Yeah.
Just a question, a slide or two ago, and I think here now too. You mentioned that there was a difference between the neural rendering and the mesh.
Yeah, for sure.
So what is it if it's not a mesh? It's like a point cloud, or?
Yeah, I mean, yeah, I'll describe it in simple terms. It is a neural network that you ask it. I mean, actually, this guy is a really good thing. I know math is not everyone's favorite topic, but the input to the neural network really is, hey, what does this part of the world from this XYZ position and then this angle, what does that look like in terms of the RGB color output, as well as this other parameter, which is a density parameter, which is really just saying, is there something there? And so it just turns out when you do this continuously, does that make sense? I mean, that's basically how it answers the question of even putting a color from a certain perspective.
How is it like an OBJ or like an
no,
file?
yeah, it's a neural network. So
Really?
yeah, basically it has like in this case, it might have like 1 million different parameters. It might actually be quite large. Some people have ported it to mobile phones, and you can do when I was looking at it recently, it was like, if you want to render a single model, it's like 100 megabytes. And I was like, I don't have that. So there's ways to compress it for sure. But I can talk more about that, but I think we can move on.
Yeah, I won't be real later.
Yeah, we can hit that for sure. Yeah. Moving on. Yeah. Oh no. Okay. I guess we can come back to these videos. Maybe after a break, I can get these videos up because this is really, well, this one's okay actually, but I'm pretty sure I'm gonna miss a really good demo that I want to show you guys. Because I guess I have a few videos here. Okay, so fortunately we don't have all videos. So, okay, so basically, well, I guess I just wanted you to know basically about the previous slide was that NVIDIA came out in 2022 with a way, what this video would show you is that in 10 seconds, they can produce these 3D models from a neural system. And that's because what they did, of course, NVIDIA is a super hardware intense company. So they basically rewrote code exclusively for doing this rendering for their GPUs. And of course, NVIDIA's secrets of GPUs is unbeknownst to all of us. So yeah, so basically it works really well. I can tell you, I've never actually seen what you would see in a demo here, which is an amorphous cloud emerging into the object, basically. I've never seen it render that quickly because, I don't know, that code, I've never bothered to touch it. It's like, you know, it's really like black magic. So, but I've seen 3D models render and come together from scratch and as fast as a minute or two, basically. So on my own computer. Okay, so this is one of those examples, actually. If you're in the business of trying to make meshes and you want to use something that has a nerve kind of foundation to do it, this is a really good go-to. It's not hugely popular. It's not perfect either, but it works really well. And you can watch it, you can fine-tune parameters and stuff like that. And it will output an OBJ or like a GLTF or something like that. So it's a very useful tool to bridge that gap. And we've used this to basically go ahead and you know, go from a nerve-based model to something that's output. We'll see if, oops. Yeah, so this is this 3D demo here. You're welcome to actually take that QR code, capture it. If you have an iPhone, you'll get an augmented reality view of basically this Strelitzia, this bird of paradise. And hopefully some servers don't crash, but basically what's really cool is that this model here was created with this NeRF to mesh system coming from just iPhone photography. So it came through, some of our own AI. We had to pre-process and post-process a variety of things, but this is practically completely automated, and it was produced in a matter of minutes. And it's not perfect. I'll emphasize that, as our previous presenters were mentioning, like there's this balance between perfection and performance. This is leaning on the side of performance. The mesh is not that big. So you're looking at something like 5 megabytes, 10 megabytes, something like that. You can compress it further with other approaches. You can choose the size of the texture. It automatically UV maps textures from the nerve. It's quite neat. It's a really good, powerful tool. And yeah, we've started using this with retail clients, basically, who sell plants for a business to create 3D models of their plants, basically. Okay, so I wanted to switch gears because I think like this is awesome what we're seeing, well, what we're seeing right there actually, but just try to not think about that for a second. Like the 3D reconstruction tools of the past, 3 years, as I was mentioning, the neural radiance fields and everything like that, basically have fantastic results if your objective is definitely to have perfect accuracy of the 3D model. I think that's really essential to say because some of us really do care about accuracy, especially if you're in a horticultural scientific, domain. You want to know exactly what the real shape, size, and textures are of the plant, in this case, that you're scanning. In other applications, that's not essential. And so, it turns out that if you could get a generative AI to generate, let's say the unseen portion of a plant of which you've only seen a single image of, that starts to look pretty compelling in a lot of real world business scenarios where you need to just create lots of 3D models very quickly. So what we're looking at here is definitely in that DALL-E space. This is next level DALL-E, I'll have to say. This came out like the day before Thanksgiving. And this is basically called stable video diffusion. What they did, each of those 4 little moving crazy GIFs is, all it originally was a single photo. So basically, you hand this photo to the system, and basically it proceeds to render an animation that is completely hallucinated by the AI system that has never seen this scene or this image. And I really must emphasize that that's absolutely true because I've tested it. I may have to get my video access system working to show you the next demo, but I'm definitely going to show you because it's pretty mind-blowing that when you know for sure the AI has never seen this thing and it can completely imagine what is apparently a photorealistic simulation of other parts of the scene. This is, yeah, go for it.
Not really a question, but I'm just mind blown by this.
Seriously.
I can't believe this is happening.
Unbelievable. Agreed.
I've been generating a lot of images through DALL-E, and just yesterday I was thinking, I wish those pictures would move.
There you go. This is your tool. You can use it right now. Yeah, this demo link you can use it. If you can pop your own image into it right now. We'll probably overload the servers because I think they tend to have just a few folks per time, but take a note of that, pop your own image into it. It takes a while. It takes like, I think even once it starts computing for you, it takes like 30 seconds or 60 seconds or something. But no, it's so cool. And if you're an architect and you've rendered a neat 2D photo, watch what happens when you put it into this. They've designed the system to be aesthetically pleasing. I've read the publication, it's quite neat. And basically, they've also designed it to do like sort of professional style camera panning, as you can see. So, it's like slow moving, cool panning. You just get that built into the AI. What they really emphasized in their system though, and this is super important to bring this back to Earth, where we're interested in, basically this system was fine-tuned for this particular application. But when you look at the publication and the techniques that they describe, I'm 100% certain that you can customize it for horticultural rendering, garden rendering applications, at least, and as well, of course, for many, many applications outside of our scope of interest. So, yeah, I will have to get you the demo. Sorry.
Is that an issue on your end, or is that something I should get IT down here, get admin?
Oh, you for the demo?
Yeah.
I can
have to share your file.
I can do it. Yeah, I think what we'll do is we'll take a short break after this because there's another talk that I have to give actually.
I'd like to request X. I didn't know.
And then I'll just give requests and then I'll do a quick recap, not of talking, but just showing talks. Okay, so Yeah, so anyways, I was going to show you, and I will show you what was one of the renders that you've already seen. It was this landscape that was 3D modeled. And basically, it not only says you can't move it, but it's prevents it. There we go. Okay. So anyway, so I'll show those demos. I think that those are the most remarkable. That's probably the most remarkable demo that video, because it shows you how good the AI can get at hallucinating. What I wanted you to see is what has been released and is available to you as well, because I think that really the direction that I want to communicate is that you know, when your task is to 3D model lots of objects, you know, of which I know our last presenters definitely have this problem, you find yourself in a position where, indeed, you know, you're willing to take a lower quality 3D model, basically, if it means you can get it done faster and you can have more interesting 3D models in it. And so in the aesthetic applications, entertainment, arts, but also I think for e-commerce, basically, you're going to find the case where a single image can be sufficient to generate an entire photorealistic 3D model, of which that 3D model that you see on the screenshot here is not. That's not a photorealistic model, but in fact, that's a real 3D model that was created from just the image in the middle there. And what it does, here's what's really fascinating. And I really want to emphasize this pipeline, because at this point, I think Rico is going to go all in on it. Although my CTO is not 100% on board yet, so good reservations. But basically, it's really fascinating that you can have an AI system that is tasked with simulating other viewpoints of a picture, and then you can use the same exact technology as DALL-E, where its job is to create an image that it's never seen before, and it's trained on real images. And my point is that basically, you can literally have a DALL-E sort of backend for your AI reconstruction, 3D reconstruction system. And the DALL-E backend, get this, can be fine-tuned on your data set, your horticultural data set, landscaping data set. So basically, you can have a system that's not only able to generate some sort of detail, but it's seen, let's say, for example, and I'll get to that in the next talk on plant data sets that we've been working with, it's seen potentially millions of images of all of these species, and you can condition it on the species. You can say, hey, I want you to generate a Monstera deliciosa. And, you know, and you give it one image of the Monstera that's from a real retailer who actually, you know, is selling this real Monstera deliciosa. And you let the AI generate the rest of it. And the most important thing to know is that it's not actually completely random. You would think, okay, good luck with that, but you force the AI to learn to generate from actual multi-photo scenes to actually do its best job of what you would describe as the most probable reconstruction. And that's so important to say, because this is, you know, in the space of being accurate, we really care about it, especially retailers care about it. They don't want to mislead their customers. So if you have an AI system that can turn around and show and help the customer see as if you were looking on the other side of the Monstera plant, it still looks like Monstera textures. It still looks like Monstera geometry. And it was just what probably existed, even from your human perspective in your own mind, what you would have things. So I think that's the future, basically. And I am going to show you one amazing demo of this. So this, I'm not even going to talk about this, because I just think, yeah, this is not the right answer to go into that. But, oh, did I have it? Oh, is it here? Okay, great. Sorry, that was a little out of order, but that's fine. This is what I wanted you to see. So this is from Adobe. And basically, on the left side in the left column, those are input photos. On the middle is a new rendering created by the AI system. And on the right is a depth map to prove that it's got 3D, you know, capability.
It's a new rendering at a different perspective.
Yeah. Is it right? Oh yeah. So basically, how did it do this? This is what they did. This is what they used. There's this brand new data set from another big AI pioneer called Allen Institute of AI, came out of Microsoft. And basically, this is 10 million of just amazing 3D models. I think they did an analysis and they said like about 1 or 2 million of their 3D models are actually really good aesthetically and highly, you know, accurate in these kinds of things. They scraped these 3D models off of GitHub and all kinds of places. These guys are web scrapers, bad web scrapers. this is the future actually, because what they demonstrated, this is my last slide for this current talk. Basically, this is spectacular. And I know you're looking at a graph and you have no idea what none of that is. I just want you to know one thing. The graph is basically saying that the more 3D models that the AI sees, the more photorealistic it can generate new perspectives of a real 3D model from just a single image input. Both of those pixel nerf and 0, 1, 2, 3, those are both systems to create 3D models from a single image. And so this is, if you're into science, I think we all are. Now I really want to stop here, and this is so important to stop here. And this is also my pitch to you. We have Gina in the back. So this is my pitch for hypergator access, actually. So what you see here is that as you get bigger data sets, the intelligence, so this PSNR, what it stands for is photorealism. Just think of that. And the photorealism goes up. And what we see here is not a logarithmic trend where it's declining, diminishing returns. We see a trend where if we just give it more data and more compute, guess what? We're going to get photorealism out of these things, like on whatever we train to do, basically. And anyways, I think this is the future. So that's it for this current talk. And then we'll take a small break and I'll get the demos turned up.
We're halfway through the time. I want to do housekeeping, but Ryan, did you have to leave before 5? No. Okay. Great. I don't want to rob anybody's time. And I think at the rate we're going, we can still make it.
Go for it. And then what about the demos actually?
But can you do the next talk and then we'll take a break?
Sure. Yeah, it's not good. Okay, yes.
I only came in late, so I don't know what the background is, but who actually owns the data in the end?
That's a big question. It's a.
Are we just collating data for large companies?
No, it's a great question. I think the short answer, a lot of this is open source. So this Observerse is an open source data set. Anyone can use it to train this.
No, there's underneath there's a major conversion to there's a trained program. The trained program is what generates things.
Right, that's right.
And does that belong to, is that open source?
The short answer is that yes, actually. Pixel Nerf, these two systems that generate the one image to 3D is our open source system, actually. So it depends. Some of these companies, it's an important point. This Adobe project is not. I wish I had it. And I want it, and I want to train a system to beat them at their own game. But it's a great question. Yeah.
This might be a bit of a fun question. I've recently noticed that the captchas have changed from identifying images to rotating a 3D model. I had no idea what it was for, but I take it that it must be training data for a system like this.
Oh, interesting. Oh my gosh. Yeah, Google would do that, right?
I think that's what the initial where it's like select everything that has a motorcycle or something, right?
I love it. Okay, so
you want to fix your videos too? Or
let me see if I got.
You have to go into.
I don't think I have any. I don't have any more videos.
Well, the ones that were displayed.
You want me to fix them now?
Well, I'm not sure. It's just a matter of setting sharing. Is it Google Drive?
Let me get my computer. I think I was right.
I'm gonna just barge in and give him a hug before I go back to work.
This is a great. Actually, she's the reason why we're here. Actually,
Doesn't it sound good?
You made the intros, yeah.
Hey everybody, I'm Gina. I knew Lance when he was an undergrad. I didn't understand what he was talking about then either. So
are you still? I don't know if yeah, we have to catch up.
And I same thing.
Yeah,
and Reagan Garner's on her way.
Oh, I love it.
Direction. See,
great to see you, Gina.
They grow up and be awesome.
Gina said some nice things, and I'm like, I might be the craziest person to come to you.
We like you anyway.
Oh, I appreciate it.
He's so interesting.
Okay, so yeah, Howard, I think it's gonna be a little bit too much.
Just one is it Google Drive that has the videos?
Yeah, Google Drive has it, and I can make the permissions work if we keep stalling for a few hours.
Okay, no, if you just do your favorite one, maybe it's.
No, you're fine. Yeah, that's a great.
This is why
I have this minor issues. Honestly, that last demo from the generated video is so spectacular and it blew my mind so hard that I think Yeah, that's right. It's dry.
How big are those OBJ files that you generate?
They can be quite small because the systems, you basically tell it how many vertices or how big you want to give it.
I have a question. You mentioned different models. Are these owners publish their pre-trained model to the public?
Yeah, a lot of them. Most of that's why I'm saying like the thing that we lack access to is compute actually, because a lot of these data sets are open. That's why again, well, whoever is listening from NVIDIA and hypergator folks, I really think that there could be a huge opportunity for us here to slam dunk. Okay, so I'm changing permissions on these videos right now.
I have a question like when they build a digital twin from NVIDIA or they cooperate with other industry. So they spend a lot of money like use a fancy camera to like scan a whole environment of the warehouse. So for this you can use one image and build a 3D asset. It can save a lot of money because I think I got the name of the company. So they only have found just like a scan one warehouse is cost them a lot of money. So they now they just doing one. They have I don't know how many warehouse they have. So they were saying because it's very time consuming and very expensive.
Absolutely.
I was thinking if we can use one image to create 3D.
I think we're getting there for sure. Yeah, no, I think within a year or two, you're going to see some amazing open source models and probably just applications that you can use just with your phone that are fast. Right now, it's all really clunky. It's like the big computer in our room, So it's very slow. It's not fully trained to do everything. The one that I showed you, which I got new demos actually, so I just changed that. But I think we're getting there. I wouldn't bet on it right now. Although I'm crazy and I'll bet on it.
But do you think we also need to collect a huge data set to pre-training all these models? Get them better?
The short answer is yes, I think, but however, these large tech companies are doing that. And not all of the data sets are released, but I'll talk actually in the next presentation about something that's really meaningful here. Because you can, my point is that there's enough that's open source that if you want to go in this direction, I guess there's a difference between being a developer who's able to fine tune something and being able to use an application off the shelf right now. It's not ready to be used off the shelf. I just wouldn't pitch that. But I think it is ready for developers to show up and really hit it hard. And then next year, the year after, they'll finish. And I would just expect that this is happening. It's a strong trend that's on the shelf. Okay, we got some videos. So
it's a fantastic tool, but I think it still needs the application because if I happen to have this plant on my phone, I will just take a camera and walk around it and create a 3D.
Well, the main application is, I think there's many applications, right? But the previous presenter was pitching something right in line with this idea of like a plant picker, something that helps you choose the right plant. And it's really about, also I'm not sure, what's the background? Yeah. What's your name?
Gail.
Gail. Yeah, cool. And which department are you in?
In environmental horticulture.
Oh,
but
cool.
I teach the residential landscape design classes.
I was loving what you were talking about before. I mean, what she was describing was that, she has to visit the nurseries and the inventory is not always there, which is its own problem. But, just the ability to take all of the inventory and suddenly bring it to you in augmented reality. We think that's the $1 trillion opportunity to change the face of retail for home and garden. If that makes sense.
Why wouldn't you just go around and take a picture of each and put them on the web page?
You mean like us as the people working on the problem?
Anyone who wants to represent the inventory, because you don't want to have hallucinated inventory.
Yeah, I mean, inventory is one problem, but the ability to simulate, in a 3D render, what your landscape design would look like, that's a different thing. And that's what we're talking about, is creating 3D models for that application. Okay, so this is
That is very,
great.
creating the 3D models, that's.
Yeah, exactly.
For other purposes.
For sure, yeah. So this is, so in the very beginning of the slide and a few times, you've probably seen this picture. I didn't generate the 3D models for the scene, but everything is a 3D model. It was rendered. And the reason why I'm emphasizing that is because I know for a fact, this scene doesn't exist. There's nothing like this in the real world. And here we go. Oh, what the heck? Is it gonna, there we go. And here we go. Look at that. It's just a hint. But the reason why I'm saying wow is because it's literally hallucinating even the bokeh of the camera. It's insane.
Depth of field. Oh, that's.
It's outstanding. Yeah, depth of field is fully there. This is the future. You know, get ready. So this is another thing where I took the scan of this plant. I know for a fact what it's about to, I've never shown it. It doesn't have access to my private data set. So this is a simulated scene. And you can see it's a little wonky, but it's amazing, right? So it preserves the texture. It has a sense of 3D. This thing just has a great understanding, roughly. Look at this little cut off stem right there. So it's, you know, I actually think if you train it on more botanical data, you give it access to more pictures of plants. This data set was, these guys don't care about plants. They don't care about us. So, you know, so we'll train it on botanical data. And then I think you're just going to get topologically, you know, reasonable renderings, especially when you say, hey, I know the species and this is what you expect. So anyways, this is incredible. But you can see how the text kind of gets even more garbled here. Anyways, there's one more demo because I promised those demos. Where was it? This it? Okay, yeah, this was the super fast. And that's literally how much time on the NVIDIA's system it takes to render the entire scene and to properly reconstruct the entire 3D model. So NVIDIA recently gave $20 million or something like this to I want to push this hard because I think we have such an opportunity here to get this all coming together for us. So, okay, so that's it for this talk. Yeah.
So, I mean, I guess it almost seems like a foregone conclusion that there will just be DALL-E for 3D models.
Yeah,
like
no question. There's no question about it.
So that's why you mentioned earlier a model like Quixel or whatever, like maybe
exactly
it
right.
doesn't make sense.
I was telling you, I was like, that's not the future.
I see what you mean.